which I think we learned about, that is the equation of a level surface. So we have this level surface living in R3 here. And we also learned that if you take so in this case, this will be f of x, y, z is equal to x, y squared z cubed, which is equal to a constant k, which in this case is 8. And we learned that if you were to take the gradient of that level surface and evaluate it at some point, let's say 2, 2, 1, that gradient will be orthogonal to the surface at that point. So if we want to find the tangent plane to the surface at the point 2, 2, 1, we can use that gradient as a normal vector for the plane. And then we just need a point on the plane, and we have that. It's 2, 2, 1. So for our plane, the equation of that will be the gradient of f evaluated at 2, 2, 1, dotted with our r vector minus r naught, which is 2, 2, 0, no, 2, 2, 1, equaling to 0. Does everyone sees that? So what we'll do is we'll just take the gradient of f. So gradient of f will be the vector composed of f sub x, f sub y, and f sub z. So we just need to figure out what each of those are. So if f is x, y squared, z cubed, oh, right up here. If you take the partial with respect to x, you just see there's one x there, so it'll be y squared, z cubed. Then with respect to y, the 2 will come down, we'll have 2x, y, z cubed. And then with respect to z, the 3 comes down. You have 3x, y squared, z squared. So that's the gradient. And now we need to evaluate it at x, y, z equal 2, 2, 1. So 2, 2, 1 will have 2 squared times 1 cubed, 2, 2, and then 2, and then times 1 cubed. And then 3, 2 squared, 1 squared. So we just have to simplify this. So this will be 4. And then we'll have 8. And then for the last one, we'll have a really big number, 24, yeah. Okay, so we found the normal vector, so we can plug that in. So we'll have 4, 8, 24, dotted with x minus 2, y minus 2, and z minus 1 equals to 0. So if we go ahead and do that, we'll have, I'm going to write that up here because that went right over the answers. So we'll have 4x minus 2 plus 8, y minus 2 plus 24, z minus 1 equals 0. And it looks like they've simplified it. So what we'll do is we'll divide everything by 4. So you'll get x minus 2 plus 2y minus 2 plus 6z minus 1 equals 0. And it looks like they've expanded it, so we'll expand it as well. So we have x minus 2 plus 2y minus 4, 6z minus 6 equals 0. So if we move, it looks like they have the numbers on the other side, so we'll move all the numbers over. We have minus 2, minus 4, minus 6, so that makes minus 12. So you have x plus 2y plus 6z equals 12. So x plus 2y plus 6z equals 12, so it's C.
Can you just look straight at that vector and see that that number is like a scalar multiple of